Hey guys, what's up everybody? Welcome back again to another video from the Apex Academy of Mathematics. We're learning the language of the universe begins here. My name is Akin, otherwise known as Apex Selenium, and on this channel we simply break down your fundamentals, we rebuild you as a student, and we try to unlock the genius that lies within you. Alright, so of course this video is a continuation from the last video, which was of course posted. You can see a link in the description below. All right, and you can actually see the image here popping up on the screen right now for what that video looks like. So do please go ahead and check that video out before you watch this one, because as you can see here on the screen, we have already done some working out here. All right, so watch that video to see how all of this was unfolded. All right, I'm sorry. Okay, so all right guys, so thank you for tuning in again, and I hope you have enough time to spend with me here to watch this video, because of course this is a detailed explanation of the laws of indices. And if this is one of your biggest problematic topics in your at your school, well, of course this is a channel for you guys. Here we explain everything in baby steps for you, so please stay tuned, and of course like this video right now. Of course smash the subscribe button and turn on your notification bell right now. All right, good. So let's jump right into the video and continue from where we left off. All right guys, so here what we have, we're going to just erase this part here. We need some space. Let the space here. All right, we need a bit of space here. Let's erase this part here. All right, we're gonna just move this up a little bit here. Right, and move this up right here. Good. Okay. All right, so we have basically a -1 here. Let's just zoom it up a little bit. We have a -1 here. We have a 3 here, a 4, -7, and a 4. That's what we had here. All right, so let's just zoom out a little bit and take care of this part. Now I really wanted to put this example in the last video, but the video was a bit lengthy, so I did not want to waste your time. So I wanted to do a combination of the multiplication and division property in one, because we do see these examples all over in the textbook. I'm sure probably you're looking at your textbook right now, you see this very same example here. So let's jump right into it. All right, so once again we have coefficients 5, 4, and 2, but this time we are doing a combination. So we have 5 multiplied by 4, and we're going to divide that by 2. Okay, so we know that this is the PEMDAS property right here, PEMDAS principle application here. All right, so we were going to have to multiply then divide. So please, there's a link in the description below for a video on how to do PEMDAS. Very simple. All right, so do check out that video right now. Oh, after this I should mean. Okay, all right, so here we have a base x, so we're going to write that base here, and the power here is -1, and the power here is 4. But because we're multiplying, multiplication wants us to add, so we're going to add the 4. But over here we're dividing, so because we're dividing, back this power here, which is 4. Okay, very good. All right, so just repeat that. The power here is -1, wants us to add this power to it, but division wants us to subtract this power from it. Okay, the base here again is y. Okay, the power here is 3. Multiplication wants us to add the -7 to it. But division wants us to subtract this power here. But wait, there isn't a power. What power is here? Is it 0? Is it 1? Is it 5? Maybe I made a mistake. Actually, did not make a mistake. There is a power of 1. It is understood, so we don't usually write it there. Whether it's given in the question or we're writing in our answer, if there's a final answer of 1, then we just simply do not write anything. Okay? All right, good. All right, so here what we have now is 5 times 4, 20. And 20 divided by 2 is 10. So our answer in our base is 10. So we have base x, and then we're going to simply work this out. So here we have 4 minus 4. So we can simply see that these two will cancel out each other. Okay, so 4 minus 4 is 0. So our answer here is minus 1. But if you wanted to, you could simply say alright, so you could simply say I owe 1 and I have 4, pay the 1 I owe and I have 3. And of course, now that I have 3 and I owe 4, I pay the 3 that I have and I'm still going to owe 1. Alright, so that's another way of doing it. You could just use the owe and have technique. Alright, so here we have the base y and here's a sign clash. Look at that video too. We have videos on sign clashes, so do check that out. Multiplication and division of integers. Okay, so sign clash is a minus, so 3 minus 7 is minus 4. Okay, minus 4 for this part here, minus 4, 3 minus 7 minus 4, and minus 4 minus 1 is minus 5. Alright, at this stage guys, if you have been watching most of the videos on my channel, you should not be using your calculator. If you are, put it down right now. You should be using your head, because of course we have a principle for working these questions out in our head. Okay, all right, good. But you can use your calculator to verify that our final answer is correct. So the answer is 10 to the minus 1 and of course y to the minus 5. Okay, there's another way to write this. We could write it in its positive index form. So we have 10, because this is raised to a negative power, we put it under the 10, and this is also raised to a negative power, we put it under the 10. So we could have 10 over xy. All right, don't pay attention much to this. This is acceptable, but this is more presentable. Okay, all right guys, so I hope you guys got that. That took a little bit longer than I expected, but the important thing here is that you understand exactly what was done. Okay, so let's move on to a couple more examples that we have on this page here. So here we have the negative index property here. That's what we have here, negative index property. So we're going to explain this part here. I do not have any examples, so this is going to be a very short video. Negative exponent property that we have. All right, here we go. So if a number has a negative index, a negative power, a negative exponent, whatever it is that you refer to it as long as a number has a negative index here is the minus 3, we simply reciprocate the base. And of course what we do is we change the power from negative to positive. All right, so here we have this 3. You must be wondering, where did this 1 come from? And there wasn't a 1 here. Well, there actually is a 1 there, because 3 is a rational number, believe it or not. It's not just a whole number, but it's a rational number, so it's already over 1. Okay, so by turning it upside down, that's where this 1 came from, and that 3 went down to the bottom. The minus 3 changed from negative to positive. Okay, all right, and then that's equal to, this is the exact value, because 3 to the power of 3 means 3 times 3 times 3, so that's equal to 27. All right, so sometimes they may say, hey, leave the answer in its index form, or leave the answer as its exact value, so depends on what it's been asked for. Okay, all right, now another way that I do look at questions like these is that if I know what the value of 3 to the 3 is, then I know that 3 to the minus 3 is the reciprocal of that number. So I know, because 3 to the 3 is 27. So I know that if this was a minus, I know the answer is 1 over this answer. That's another way that I look at it. Okay, all right, so I hope you guys got that little example there. Of course, you know that the base may not necessarily be a number. It could be a variable. Okay, so in this case here, you can't do anything much except simply reciprocate this value here. So the 1 goes up, the x goes to the bottom, and the negative 4 change to positive, and there isn't anything that you can really do to this. It's just 1 over x to the 4, because we don't know what x is, so we cannot raise it to a power of 4 to get a value. So we are answer will be left in an expression form. Okay, all right, so that was a quite straightforward for you there. Alright, so we're going to just look at the fact that our quantity may not necessarily be a whole number in a sense, but it may be definitely a rational number. So here what we have is 3 to the power of 4, well, not 3 to the power of 4, I'm sorry, 3 over 4. Okay, so we can have fractions now that are raised to a negative index, and so in this case it's quite straightforward that the 4 will go at the top and the 3 will go at the bottom right here, and the negative 2 will change to a positive 2. Okay, so I know probably you're looking at this and you'll be saying, all right, then how comes the 3 was at the top and then it went to the bottom? Should this 2 go to the bottom of the 3? No, the minus 2 here is powering both the denominator and the numerator, all right, because the 3 is not a number and the 4 is not a number. The 3 over 4 is the number. So the 3 over 4 is like almost saying replace the 3 over 4 with like 10. So this is really saying 10 to the minus 2. Really, that's kind of like what I'm saying here. So don't worry about moving the minus 2. It's not attached to the 3, it's attached to the 3 over 4. So I wanted to just make that clear for you, okay, if that's a bit confusing. So don't worry about the fact that, hey, this 3 went down to the bottom, so because you thought that it was like attached here. No, it's just attached to the whole entire fraction, so the 2 remains where it is. All right, so here is where we have the power to power property, which again is going to be in another video, so do check out the video when it's posted. Stay tuned, and of course turn on your post notification bell and smash the subscribe button if you want to know when that video is posted. Okay, all right, so here what we have is 4 squared. We square the 4, we get 16. All right, so that's equal to 4 times 4, and this is equal to 3 times 3, because the square goes on the inside, square both numerator and denominator. Okay, so we get 16 over 9. That's the exact value, and this is the most appropriate way to write your answer. All right, or you could say simply 1 and of course 7 over 9. Okay, mixed fraction form. All right, so moving on to the final example, guys. So this one looks a little bit off. You're like, oh my god, I do not want to learn how to do this question, but in fact I really think you want to learn this one. Okay, so here what we have is, not only do we have a fraction for our base, but we have our index being a fraction also. So how do you handle a situation like this? It's the same. It does not change. It did not say, the law did not say if we have a fractional index or we have a whole number index. It says that if we have a negative index, so it doesn't matter what the index is, as long as it's negative, the rule states that we take the quantity and we turn it upside down. So the 16 goes down, as you can see here, and the 9 goes up top. So that part is good, and the power changed from minus to positive. Now, another mistake that students make is that they completely forget that the rule did not say we should reciprocate the power. We should reciprocate the base, the quantity, and change the power from negative to positive. So a lot of students will do 9 over 16 raised to the 2/3. Oh gosh, that's a horrible mistake. All right, that's just when you're not listening. So please, here I am begging you, do not do that ridiculous mistake. Okay, all right, good. All right, good. So here we go. Okay, all right, so good, we are back. All right, so 16 goes down, 9 goes up, negative, change to positive. We keep the 3 over 2, we don't change it. All right, so we have a power to power here. Now this here will be there's a variety of ways to work this out, variety of ways. So what I've done here is that I've attached the power to the 9, so this becomes 9 to the power of 3 over 2, just as how in this previous example I said 4 squared. I can see the same thing here, 9 to the power of 3 over 2. All right, so this is not 9 times 3 over 2, so please do not say the 3 cancels the 9. That's another fundamental error, guys. This is a power. this here is a power, this is a base, so you cannot use powers to cancel base. Okay, all right, good. So here, and I attach the power to the 16 here. Now this here is what we call the root property law. There are a couple of ways to do this. All right, there's a couple of ways to do this. I won't be doing the root property law, or nor will I be explaining it in this video, because I do not want to confuse you. But what I want to do here is to show you that 9 is what we refer to as a perfect square. Okay, perfect square. I do have videos coming out on perfect squares, square numbers, different types of numbers, different sets of numbers. So do of course smash the subscribe button and turn on your post notification to know when those videos are posted. Okay, all right, but what I want to explain to you here is that we need to simplify this. This is simplifiable, if that's a word. So 9 can be written as 3 squared. Okay, because 3 times 3 is 9, so we can write it in exponential form, 3 squared. Okay, all right, times the power that was there. So this is a power, this is a base, so 3 squared is 9, but the 2 is acting as a power, so we're going to times it now back by the power that was previously there, which was 3 over 2. 16 is also a perfect square, so that's 4 squared. And we're going to times that now by the power that was there already, 3 over 2. All right, now since as we have power and power, we can cancel, and power we can cancel. So what we have here now is simply let's go here. What we have here is 3 to the 3 divided by 4 to the 3. Okay, so do look out for videos where I'm showing you how to simplify exponential quantities using a shorter version other than the law. So look out for that video. Okay, all right, so 3 to the 3 is 27, and of course 4 to the 3 is 64. So our answer here is 27 over 64. All right guys, so this last example was a little bit tricky, but of course you can rewind the video, pull back the buffer, and of course check out how exactly I did this again. Rewatch it as much time as you possibly can to get it, but if not, do watch the remaining videos coming up so you can understand exactly how we went through this. So yeah, definitely. All right, so guys, thank you so much for staying here and watching this final law on this video, the negative property. Do look out for the other videos. We are going to be explaining laws 4, 5, 6 and 7. All right, and if you have any problems with the application law, please of course take a look at the screen right now. Do check out the videos on, of course, laws 1, laws 4 to 7 and law 5 to 7. Sorry, laws 1 to 4 and law 5 to 7 videos that are in the link is in the description below. So please do take care, and I will see you guys next time in another Apex Academy of Mathematics tutorial video. Do enjoy the rest of your day, evening or morning, and I will see you soon. Bye bye.